Today, we're going to go over the X method, some people call it the big X method, and the box method. So first, we'll start with the big X method. So we're going to start with an example of a quadratic that we need to factor. There we go. So the big X method is literally that we make ourselves a big X. It doesn't have to be quite that big. Again, it's always messy, or it can be messy, and that's okay, but it doesn't have to be perfect. So the big X method, we put A, C, and B. So it's also another form of ACB method. So if we remember A, the standard form of a quadratic, A is the first coefficient, bx, b is the second coefficient, and c is the last. So if we're doing a times c, for us, we have our little invisible 1 here. That would be 1 times 14. So 14 goes in my top spot there. Then b would be here. That would be 9. And ACB, or the top spot, we're looking for factors that multiply to get 14 and add up to or subtract to get 9. So that's where we're headed. So if we can try to think of factors of 14, you can think of 1 and 14. That doesn't really add up to 9. So the only other one for 14 would be 2 and 7. And since all of our signs are positive, I can think of plus 2 plus 7. That adds up to positive 9. So immediately, if I don't have an A term, or my A term is 1, immediately those factors that I get in my X here are the factors that go right into here in my parentheses. So the answer to this one would be X plus 2, X plus 7. And if we were asked to just find the factors, or just factor our original equation here, this would be our final answer. These would be the factors. If we are asked to find the solutions, find the zeros, or solve for x, we would set this equal to 0, and each of these are an option, meaning if this whole thing is 0, the entire problem would be 0. Another option would be if this portion is 0, that whole thing would be 0. Because this is being multiplied, so 0 times anything is still 0. So that's why we call these the zeros, or the solutions, or the roots, or the factors if we're leaving them in this form. But again, the zeros, or solving for x, would be when we set each one equal to 0. So I'm going to set each of these equal to 0. And if I take it one more step, I would subtract 2 from both sides. So in this case, x equals -2. And for this one, subtract 7 from both sides, x would equal -7. So these are our two solutions, our two zeros. And real quick review, if these are a parabola, this would be where we cross the x-axis. So in this case, these are both negative, so it looks like our parabola is over here somewhere at -2 and -7. When x is -2 and x is -7, our y is 0. So that's where we cross the x-axis. Those would be our x-intercepts. So that would be the solution, or those would be the two solutions for that using the X method. So let's try the next method. We're going to call this the box method. And many of you have probably been shown this, or if you haven't, you may find it useful. We're going to make a little box. So when we're doing quadratics, you could certainly do more boxes if you have more terms. But for this example, here is our little example. So if we are trying to start from this end and get to our factors, again, when we're factoring, we're trying to get to our two parentheses. So here we're going to put the quadratic in the box, and you'll see how that makes sense later, or in a second. So essentially what we're doing with the box method, and sometimes for visual learners this is really helpful, but you can see that we're going to multiply my column and my row. So we have to make sure everybody gets to everybody else. So essentially what we're doing here is this column and this row goes in this box. So the only two things that get us to x squared are x and x. Then you'll notice I left these two diagonals blank because these are the two that have to add up to negative 4x. So I have to figure that out. So I go right to my last term, and this is really similar to my trial and error method. You can check that video out as well, because it might be easier than drawing the box and it takes up less room, but it's all the same format. So if the box makes more sense to you and you can see it visually, by all means use that. So we have to think about this negative 5, and what I need to do is have this column and this row multiply to get negative 5. So the only factors of negative 5 are 5 and 1. And it doesn't matter in this case, since I just have x's here, it doesn't matter which order I put them. I could put the 5 down here and the 1 up here, either or, it doesn't matter. So now I have to work on my signs. I need this to be negative 5. So 5 times 1 is positive 5, so one of them has to be negative. So I have to determine that by adding up to negative 4. So I'm going to think about that. Let's see, if x minus 5, if I have a negative 5 and I'm adding it to a positive 1, so here I'm going to go into this box. This would be this row and this column that I'm multiplying. So negative 5 times x, that would be a negative 5x, and this row and this column would be just a positive x, positive 1x. So I'm just going to put x here. So here I'm double checking that they add up. So negative 5 plus 1, that does get me to negative 4x. So these right here are my factors. And this always looks a little bit funny going this way. But these numbers here are what my factors are. So same as what we've done in kind of the x method and my other methods, you can see in other videos. But as soon as we get those factors, if we don't have an a term, so you'll notice here we didn't really talk about a, c, or b, and maybe that's easier for others. So if you have a hard time remembering what a, c, and b is, sometimes box method is helpful because you can visually see which rows and which columns we're multiplying. So again, I always say FOIL as a quick review. If you never learned FOIL, or if you did, here's a quick review. FOIL is a great way to check and a great way to multiply two parentheses. So the way to check that is my two first terms, that would stand for f. I'm going to multiply those, that gets me to x squared. My outer terms, that stands for o, that would get me a negative 5x. Then my inner terms, that stands for I, that gets me a positive 1x. And then my outer, oops, I'm sorry, we already did outer. So then my last term would stand for L. That would be a negative 5. So then here I can combine like terms. So this would be x squared minus 4x minus 5. So that was just a quick way to check that I did indeed get this. So all of these factoring methods, I always think factor FOIL go together. I always say they are a way to get us to that. It's like backwards foiling. So we're trying to figure out what gets us, when we FOIL, gets us back to our original. So that would be the box method there. And again, if we needed to solve, if you needed the factors, this would just be your answer. But if you needed to solve or find the zeros or the solutions, we would set each of these equal to 0. And then we would solve for x. So if I isolate x, I would move the 1 over, that would be negative 1. And here, move the 5 over, that would be a positive 5. So those would be my two zeros or my solutions for this quadratic. So that's using the box method. So these were two easy problems that used the two different methods, the x method and the box method. So let's move on to a little bit more challenging when we have this a term up front. So here's an example here, 2x squared minus 2x minus 24. So if we're going back to the big X method, again, we're going to have AC up top and B down below. So my a term is 2. I'm going to take 2 times negative 24. So that would be a negative 48. And then my b term is negative 2. So I need two factors that multiply to get negative 48 and add up to negative 2. Add or subtract. So I'm thinking of factors of 48. So a couple have come to mind. I have 6 and 8, and I have 4 and 12, and we already saw this was 2 and 24. I know that would be a case. So I have to think about when I add or subtract that they add up to negative 2. So 4 and 12 are a little bit harder, but 6 and 8 could work. So I have to think about my signs. So if I want the negative left over, the 8 would be the negative. So negative 8 plus 6 gets me to negative 2. Now you'll notice I can't go right back into x plus 6 and x minus 8. That doesn't get me a first term of 2x squared nor a last term of negative 24. So you'll see something there that should stop you in your tracks. So when we do have an a term in this case, we have to go back to this factor by grouping. So we did this in the T-chart method in my last video, so you can check that out if that makes more sense to you. Same thing here. We're going to replace this middle term with my two factors that I've come up with here. So, and I'm kind of thinking ahead, what goes with 2 and what goes with 24. In this case, they both do, so it doesn't really matter the order. So I'm going to say plus 6x minus 8x minus 24. So you can see here I've just replaced that minus 2x, which when these are combined, we do get negative 2x. So I've replaced that with my two factors. Then we're going to factor by grouping. So whenever I have 4 terms, that's a good sign I'm going to group. So here I'm trying to think of what can I pull out or unfactor, undistribute, or factor out of these 2 terms. So it looks like I could take out a 2x. And then what would be left over? That would be an x plus 3. And I can double check by distributing in my head and think, if I multiply 2x times x, that gets me 2x squared. If I multiply 2x by 3, that gets me 6x. So we're always kind of going forwards and backwards with factoring. Factor foil, that's what I always think of. So same thing here, I have to think about what 2 terms can I take out here. And it looks like negative 8 could come out of both. And then that would be an x and a plus, careful of your sign here, plus 3. So we just have to make sure if I multiply the negative 8 to both, that would get a negative 8x and a negative 24, which is what I need. And this grouping only works, I call it the magic only happens if these 2 parentheses are the same. So then our final answer, we're going to pull out that x plus 3 because he's common. So that is the first factor. And our second factor is 2x minus 8. So if you're asked to factor, that would be your final answer. And you can double check. Now our first term does get us to 2x squared. And our last term does get us to negative 24. And our outer and our inner does get us negative 8x and the positive 6x, which is what we needed. So that is a good check there. Always check with FOIL. So again, if we needed to find the solutions, we would set this equal to 0. That would be x equals negative 3. And then the 2x minus 8, that would be x equals a positive 8 over 2 or 4. So those would be our solutions there. So that's using the x method with an a term. So now let's try our box method with an a term. So here's another example, 6x squared minus 13x minus 5. So if we're using our box method, let's try this. Again, we're going to give ourselves 4 spots for each of our factors. So I put my first term here and my last term down here. And these 2 diagonals have to add up to negative 13x. So I'm going to keep that in mind. So again, this is similar to trial and error. I need two things that multiply to get me to 6x squared. So I could immediately think maybe 2x and 3x. That might be some place to start. And then I go right to my last term. What are factors of 5? So I can only think of 5 and 1. So I'm going to work here and work on my column. So 3 times 5, or 3x times 5, that would get me a positive 15x. And then here, 2x times 1, that would get me a positive 2x. So I need negative 13x. So this does work out. 15 and 2 can add up to negative 13 if the 15 is negative. So to do that, I would need to make this 5 negative, and that works out because I needed this one to be negative 5. So the box method is great because you can really visualize what columns and what rows, as long as you remember the diagonals add up. So now, in this case, this is our factors. So we don't have to put it back through because we've made sure that our columns and rows all work out. So these are our two factors. And this was a positive one, 3x plus 1. Sometimes it's a little harder to see those factors on the side there. So again, I can check with FOIL. That gets me 6x squared first. Outer, that's a positive 2x. And a minus 15x, that does add up to negative 13. And my last term is negative 5. So that works out. Those are my factors. And if we needed to solve our solutions, we would set each of those equal to 0. So for this one, we would add 5 to both sides. 2x equals 5, and then divide by 2. So these ones aren't super pretty, but that's okay. X equals 5 halves, or 2.5, whichever your teacher prefers, fractions or decimals. And then for this one, we would subtract 1. 3x equals negative 1, and then divide by 3. So this one would be x equals negative 1/3. So those would be our two solutions here. So that was the big X method and the box method. So hopefully those were helpful. Please feel free to comment below with any of your questions.